Ancient Egypt was not a gentle place to live. It was a furnace shaped by geography, sun, and sand. For most of the year, daytime temperatures hovered near or above 40 degrees. Shade was scarce. Rain was almost non-existent. The air itself seemed to press down on everything beneath it. This was not a climate that forgave mistakes, yet millions of people lived here for thousands of years. They raised families, built cities, and constructed monuments that still stand today. And they did it without electricity, without refrigeration, without mechanical cooling of any kind. Their survival was not accidental. It was engineered. Life revolved around the sun. Egyptians understood that heat was not something you escaped. It was something you managed. Daily routines shifted with temperature. Work began early. Rest came at midday. Nights were used strategically, not wasted. Architecture followed the same logic. Homes were not isolated objects placed randomly on land. They were part of a larger thermal system. Cities were compact. Buildings leaned into one another, sharing shade and blocking direct sunlight. Streets were narrow not because space was limited, but because shade was essential. Every wall cast a shadow, and every shadow mattered. The materials, the layout, and even the height of structures reflected an intimate understanding of heat behavior. Hot air rises, thick walls slow temperature change, enclosed spaces cool faster when shielded from direct sun. These were not scientific theories to the Egyptians. They were lived experience, reinforced every day by comfort or suffering. Modern architecture often treats climate as an afterthought, something to correct later with technology. Ancient Egyptians had no such luxury. If a home failed, people suffered. So failure was not tolerated. This is the context modern comparisons often ignore. Ancient Egyptian cooling was not primitive improvisation. It was the result of generations living inside one of the harshest climates on Earth and learning, slowly and deliberately, how to make it livable. Modern buildings are built from materials that trap heat and hold on to it long after the sun goes down. Concrete, steel, and glass absorb enormous amounts of thermal energy during the day, then release it slowly at night, turning homes into heat reservoirs. Air conditioning fights this process constantly, burning energy just to undo what the building itself causes. Ancient Egyptian homes took the opposite approach. The primary building material was mud brick, made from Nile silt mixed with straw and dried in the sun. It was inexpensive, locally available, and perfectly suited to the climate. Mud brick walls were thick, sometimes over half a meter, and that thickness mattered. Heat does not move instantly through mass. It travels slowly, and mud brick delayed it long enough to make a difference. During the hottest part of the day, the sun beat down on the exterior walls, but the heat took hours to reach the interior. By the time it did, evening had already begun and temperatures were falling. At night, the stored heat dissipated harmlessly into the cooler air, resetting the cycle for the next day. Modern walls are thin by comparison. Designed for speed, cost, and maximum interior space, they allow heat to pass through quickly. The result is a structure that overheats by mid-morning and remains hot well into the night unless mechanical cooling intervenes. Mud brick also regulated humidity. Unlike sealed modern materials, it could absorb and release moisture, stabilizing indoor conditions and improving comfort. This made interiors feel cooler even when temperatures were high. The Egyptians did not choose mud brick because they lacked better options. They chose it because it worked. Stone was reserved for temples and monuments, not homes, precisely because it retained heat too long for daily living. This was not aesthetic tradition. It was climate engineering. Ancient Egyptian builders selected materials that cooperated with heat rather than resisting it, and in doing so, created homes that remained livable in extreme conditions without consuming a single watt of energy. In ancient Egyptian homes, cooling did not come from a machine hidden in a wall. It came from the space at the center of the house. The courtyard was not decorative, it was functional, and it was essential. Most Egyptian homes were built around an open central courtyard, partially shaded and open to the sky. During the day, this space acted as a thermal buffer. The ground remained cooler than surrounding walls, protected from direct sunlight for much of the day. As the air inside the house warmed, it naturally rose and escaped upward through the open courtyard. This created a subtle but constant movement of air. Hot air left. Cooler air was drawn inward through surrounding rooms, doors, and small openings. No fans, no electricity, just physics. At night, the process reversed. The courtyard released stored heat into the open sky. Stone and earth radiated warmth upward, cooling rapidly under the night air. Cooler air then settled back into the home, lowering interior temperatures before morning arrived. Each night reset the system. Modern buildings often eliminate courtyards entirely. Interior spaces are sealed. Air is trapped. Heat accumulates. Without mechanical ventilation, rooms become stagnant and oppressive. Even with air conditioning, airflow is artificial and energy-intensive. Ancient Egyptians understood something modern design often ignores. Airflow is as important as shade. A cool space is not just about blocking heat. It is about giving heat somewhere to go. Courtyards also created microclimates. Plants, water jars, and shaded surfaces further cooled the air through evaporation. These were small adjustments, but in extreme heat, small advantages compound. The courtyard turned the home into a passive cooling system that ran continuously, silently, and reliably. It never broke. It never required fuel. It responded automatically to temperature changes. What looks like an architectural feature was, in reality, the engine that made ancient Egyptian homes livable in extreme heat. Ancient Egyptian cities were not designed to impress from above. They were designed to function on the ground where people actually lived. In extreme heat, shade mattered more than symmetry, and protection mattered more than wide-open space. Homes were built close together, forming dense clusters that blocked direct sunlight. Streets were narrow, winding, and irregular. This wasn't disorder, it was thermal strategy. Narrow streets stayed shaded for most of the day as walls cast long shadows that moved slowly with the sun. Even at noon, when heat was most intense, sunlight rarely reached the ground for long. Modern cities do the opposite. Roads are wide. Buildings are spaced apart. Glass and steel surfaces reflect and trap heat, creating urban heat islands where temperatures rise several degrees higher than surrounding areas. Asphalt absorbs sunlight and radiates it back upward, making streets feel unbearable in summer. Ancient Egyptians avoided this by accident and by instinct. They built with human comfort in mind, not vehicle speed or visual impact. Streets existed to move people on foot, not to move cars at high speed. That allowed density without discomfort. Shaded streets reduced heat gain inside buildings as well. Walls facing narrow alleys were protected from direct solar exposure, keeping interior spaces cooler throughout the day. Heat was managed at the scale of the entire city, not just individual homes. This collective approach is what modern planning often lacks. Today, buildings are designed as isolated objects, each fighting heat alone with machines. Ancient Egyptian cities worked together. Shade wasn't added later. It was built in from the beginning. In ancient Egypt, a building's position mattered as much as its walls. Homes were not placed randomly on the land. They were oriented with intention, shaped by the movement of the sun and the direction of the wind. The Egyptians understood that the sun was predictable. It rose and set the same way every day, and its path across the sky determined which walls would suffer the most heat. Openings were kept small and carefully positioned. Windows rarely faced the harshest afternoon sun. When they existed at all, they were high and narrow, designed to admit light without admitting heat. Doorways and internal passages were aligned to encourage airflow. Prevailing breezes from the Nile were guided through homes, creating natural cross-ventilation. Hot air, which naturally rises, was given clear escape paths through higher openings, while cooler air was drawn in at ground level. The result was constant, passive air movement. Modern buildings often ignore orientation entirely. Towers are rotated for views. street presence, or visual symmetry, even if that means exposing entire glass facades to hours of direct sunlight. Cooling systems are then expected to compensate for the heat load created by poor orientation. Ancient Egyptians had no such safety net. Orientation was not a design preference. It was a requirement. Walls that faced the sun were thick and unbroken. Living spaces were placed deeper inside structures, protected from external heat. Storage rooms and service areas absorbed the thermal burden instead, shielding occupied spaces. This logic extended beyond individual homes. Neighborhoods were arranged so buildings shaded one another, reducing solar exposure collectively. The city itself became a climate control system. Orientation wasn't about aesthetics, it was about survival. Ancient Egyptian builders treated the sun and wind as design partners, not obstacles. By working with predictable natural forces, they reduced heat before it ever entered the building. Modern architecture often tries to fix overheating after it happens. Ancient Egypt prevented it from happening at all. In ancient Egyptian homes, the roof was not an afterthought. It was an active part of the cooling system. Roofs were flat, simple, and functional. Built from layers of wood, reeds, and mud, they acted as thermal barriers rather than heat traps. During the day, heat rose upward, away from living spaces below. Thick roof layers slowed heat penetration, preventing interiors from overheating during peak sunlight hours. At night, the function reversed. As temperatures dropped, roofs released stored heat directly into the open sky. With no attic spaces trapping hot air, heat escaped naturally. This daily cycle of absorption and release kept indoor temperatures relatively stable. Roofs were also used as living space. On hot nights, families slept on rooftops where cooler air flowed freely. This wasn't desperation. It was intelligent adaptation. The building extended upward into the cooler night atmosphere, providing comfort without energy consumption. Modern roofs often do the opposite. Dark materials absorb solar radiation all day. Insulation traps heat inside. Attics collect hot air, which radiates downward into living spaces well into the night. Mechanical cooling is then required just to counteract the roof's design. Ancient Egyptians avoided this problem entirely. Their roofs were breathable, accessible, and integrated into daily life. Heat was allowed to leave, not accumulate. Some roofs also supported water jars or damp materials that enhanced cooling through evaporation. These small interventions lowered surface temperatures and improved nighttime comfort. What modern design treats as a purely structural element, ancient Egyptian builders treated as environmental infrastructure. The roof was not meant to seal heat in, it was meant to let heat go. In extreme climates, that distinction makes all the difference. Modern buildings overheat not because the climate has changed, but because the way we build has. Somewhere along the way, architecture stopped responding to the environment and started outsourcing the problem to machines. Glass towers rise in desert cities, reflecting sunlight in every direction while absorbing enormous amounts of heat. Thin walls prioritize interior space and speed of construction. Buildings are sealed airtight, cutting off natural airflow entirely. In this design logic, comfort is no longer created by form or material, but by air conditioning units hidden behind walls. This shift created a dangerous assumption that climate no longer matters. Air conditioning does not eliminate heat, it displaces it. Every unit pulls heat from inside and dumps it into the surrounding city. As more buildings rely on mechanical cooling, outdoor temperatures rise. Streets become hotter, buildings absorb more heat, cooling demand increases again. The cycle feeds itself. Ancient Egyptian homes never entered this loop. They reduced heat before it entered living spaces. Modern buildings invite heat in, then fight it continuously. The consequences are visible everywhere. Power grids strain during heat waves. Blackouts turn glass buildings into uninhabitable spaces within hours. Without machines, modern architecture fails almost immediately. Ancient Egyptian homes did not collapse without technology. They functioned by default. This is not a rejection of modern engineering. It is a critique of dependence. Machines were meant to assist good design, not replace it. When air conditioning became cheap and widespread, the incentive to design climate-responsive buildings disappeared. The result is architecture that works only as long as energy flows uninterrupted. That is not resilience, it is fragility. Ancient builders assumed systems would fail, so they built structures that worked even when nothing else did. In extreme heat, that mindset is not outdated. It is essential. The methods ancient Egyptians used to stay cool were not magic. They were the result of generations observing, experimenting, and refining. Every architectural decision, from wall thickness to courtyard placement, from roof materials to street orientation, was informed by experience and necessity. Builders watched how sunlight moved across walls. They noticed which winds brought relief and which intensified heat. They learned how thick walls could delay heat, how open spaces could guide airflow, and how courtyards could transform a home into a natural ventilation system. This knowledge was passed down through apprenticeships and familial teaching, refined over centuries. Modern architecture, by contrast, often resets with every new project. Digital models and air conditioning systems replace slow, experiential learning. Designs prioritize speed, aesthetics, and profitability over environmental integration. In doing so, the accumulated wisdom of thousands of years is abandoned, not because it failed, but because it was inconvenient. What ancient Egyptians understood instinctively, modern designers must calculate and simulate. What was once a living tradition became old-fashioned and invisible. The principles of passive cooling, airflow management, and material performance remain valid, yet we treat them as optional, relics of the past rather than tested strategies for human comfort. The truth is simple. The knowledge was never lost. It was deliberately set aside. Machines replaced observation, shortcuts replaced patience, convenience replaced adaptation, and the result is predictable. Modern buildings overheat, energy demand skyrockets, and human comfort depends entirely on electricity. Ancient Egyptian homes thrived without it. Their legacy reminds us that thoughtful, climate-aware design is not backward, it is timeless. Ancient Egyptian architecture offers lessons that modern design has largely ignored, yet these principles are just as relevant today. Thick walls, courtyards, natural ventilation, and strategic orientation are not outdated ideas. They are solutions born from necessity, refined over thousands of years. Courtyards remain one of the most effective passive cooling tools. By creating a central space where air can circulate freely, homes can reduce interior temperatures without electricity. Shaded courtyards also allow evaporative cooling, especially when water or plants are introduced, providing relief even in extreme heat. Modern architects are rediscovering this technique, integrating courtyards into homes, schools, and office buildings as a way to naturally improve airflow and reduce energy consumption. Wall thickness and material selection are equally important. Mud brick and other high thermal mass materials absorb and slowly release heat, maintaining stable indoor temperatures throughout the day. Today, designers are experimenting with similar strategies, using clay, rammed earth, and other natural materials to reduce reliance on artificial cooling. Orientation and airflow cannot be overlooked. Placing windows and doors strategically to align with prevailing winds, while protecting interiors from the harshest sun, significantly reduces heat gain. Ancient Egyptians instinctively applied these principles, but modern urban planning often ignores them, resulting in overheated interiors that depend entirely on machines. The key takeaway is clear. Ancient Egyptian homes were optimized for comfort, sustainability, and resilience. Their design choices were deliberate and functional, not decorative. By studying and adapting these timeless strategies, we can create buildings that respond to the environment rather than fight it, a lesson that is urgent in a world facing rising temperatures and energy demands.